Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about a crucial topic of surge protections. So let's dive right into it. Well, first you have to understand this part that surge or voltage spikes are not something that may happen. It's something that will happen. It always happens. Most of the time it's harmless, but sometimes it's like, okay, I'm going to destroy multi-million-dollar equipment kind of thing. So it always happens. It's not a question of whether it's going to happen, or this question is when it's going to happen or how severe it's going to be. And many times people will say that lightning causes, is that true? Absolutely, that is true. But be mindful, that's just one of the causes. And if that was the only cause, then we would not have to worry about it. But there are other causes that are much more severe and much more tedious to root out. For example, bad wiring. What can you do about that? Second, every time there is a giant induction motor or something like with a giant electrical loads are triggered, they create a spike, and its spikes can radiate outwards towards the holes, basically complex that is connected by the substation. So you can't do much about it. So it is something that happens on a very short duration, and generally it's less than 1 second. Actually it's in milliseconds, but be mindful. But it is very serious. Like, you need a oscilloscope to see it, and like, because if you see the waveform, it will look completely normal, but if you zoom in and then, like, okay, there was one spike that reached to like 2000 volts, one spike was that reached to, like, 600,000 volts. These ludicrous things happen. Now, same way, you will not build a home without a fuse. We have to do something similar with, basically, when we are talking about voltage spikes. For example, our system that we are utilizing on fuses, they are works on amps. Basically, it's built for 8 amps. The moment you try to draw 9 amp out of it, it's gonna stop working. So it's as simple as that. Now, why this is such a big deal nowadays rather than it used to be in the past? Because I'm pretty sure if you go back old enough and you watch even old movies, nobody is using power strips. Why, basically, what we call surge protects. Why the heck is such an important deal now? Because semiconductors are far more fragile. Like old equipments, they can just endure it, because these events, while they are devastating, they are very transient. They are like gone. Very, very sharp events. So they don't do much to old bulky equipments. But modern semiconductor equipment, yeah, they go oof, instantaneously. So this is a problem that we have to tackle. So what's the solution? Solution starts with your home, that your home must have a way to short power to the ground. Basically, you have energy coming from either from neutral terminal or from live terminal, and it should directly go to the grounding. Your home must have good grounding. If your home grounding system is not done well, yeah, bye bye, it's not gonna do much. You must have a good, stable, solid, well done grounding. Now, what we have to do is basically find something that acts like a fuse, but for voltage, not for ampere, but for voltage. Now, if this surge protection system is done correctly, generally it will be designed in such a way the moment surge is detected, it blows a fuse. Most of the time when you're talking about residential cases, it generally means it's going to trigger the MCP rather than, because it is something that you can reset. So rather than, like, trying to physically replace the fuse, you can just reset it. And it has same rating category as your normal fuses. Like, you have fuse for 3 amps, 5 amps, 13 amps, things of that nature, or even car fuses like 10 amps, 5 amps, or things of that nature. Surge protectors are also rated accordingly. It's not just like, oh, this was such tiny surge protector is gonna protect multi-million-dollar server, or versus, like, this giant wall only gonna protect. It's like, it has ratings, same way a fuse does. So what are the tools that we deploy to handle this situation? Well, all we are trying to do is shunt the current. Basically, there is a lot of energy, and we are like, you shall not go into my equipment to fry it, you shall go to grounding. Now, how the heck we do that? Basically, we have something what we call clamping voltage. Every equipment that we're gonna utilize has a certain voltage tolerance. Even if it's built for, let's say, 120 volt, for very brief amount of time, it's like, I can endure 300 volt. Brief amount, I'm talking not like seconds, I'm talking like a microsecond. It can, like, I can tolerate that. It's not gonna go up in smokes. It has some tolerance built into it. That's why most of the equipments are fine. But the moment you exceed the clamping voltage, you want something that's like, you know what, we had enough of it, go to the grounding. So we utilize metal oxide varistors. Now be mindful, this is one of the tools. There are many tools. This is one of the tool. Now it acts invert of a fuse. All it does is basically it looks at it, your live wire. It's like, live wire supposed to be 220 volts. Okay, everything is cool, everything is cool. It's 300 volts. Okay, that's not okay. That's not okay. It's 400. Yep, go to neutral or go to live. Generally it's sent to go to the grounding, and that's what it's doing. This is the whole thing. It's directly connected to everything everywhere, and the idea is the moment the voltage exceeds its break clamping voltage, it's gonna be like, okay, just go to the neutral, basically, or earthing. Most of the time it will be grounded to earthing properly, and if that happens, because there is a dead short, it will draw so much current, it will blow your fuse. Everything will be saved. That's the whole point of it. Now, How is this the only tool? No, this is the cheapest tool, and most of the time if you find any power strip with surge protection or any low end UPS with surge protection, that's what they have. Now be mindful, this is good, this is working, but this is a very basic solution. You have something bit more oomfish, where you have gas discharge tube. Now if your equipment is expensive enough, for example, when you are talking about audio equipment, especially analog variety, yeah, they're not taking any chances and they're gonna have gas discharge tubes. And if you're talking about something semiconductor like a server grade, and you're like, this puppy has to be damn secure, you may have transient voltage suppression systems which are utilizing diodes. Basically those things are even more expensive, but they are very good. Now be mindful, those are very awesome, but they do suffer with one consequence: they are not very robust. So generally you will have layers of these. If you find something very serious, it will have layers of this. It will have like MOFs, it will have gas discharge tube, then it will have TVS. It generally has a layer. So MOFs are very good for like big fish things, like it can handle the big load. Now it can handle the big load, but there's some load still gets through, because on that small delay that happens, it's like, okay, it's like waiting for that voltage. Now once it starts to become closed circuit, it takes time. During that time, gas discharge tube is like, I got this, and some voltage still will make through to your equipment. That will be taken care by transient voltage suppression systems, where we'll have diodes. So it's like, no, you are above 220, you will not pass. Now there are serious limitations to this equipment. You have to be very mindful. This is a wearable component. You could have a desktop, you could have a gaming PC that you could utilize for 5 years or 10 years. That's no big deal. You could have audio equipment that have been going on for like almost 10-20 years. That's not a big deal. However, these equipment will wear down. Inherently it has a ticking clock element kind of thing to itself, because whenever you are talking about chemistry, it degrades over time. Your basically battery degrades, your electrochemical cells degrade, your capacitors degrade. Same happens to these things. These also degrade over time. Now time itself will degrade it, and sometimes you will have one big strike that was powerful enough, it's like poof, done, gone, go home. It can't do its job anymore. It can't subvert any basically harmful spikes away. It's like, I'm done, I'm blown up, I can't do anything. Or sometimes you will have no big event, but you will have many small events that will over time will cause the same thing. So you have to be very mindful. There are limits to it. This is not something that you buy and forget. It's inherently not designed for that. It's inherently, like, especially if your equipment is very serious and very expensive, you will find something that allows you to replace it very quickly, or you will have like a time stamped properly done. It's like, okay, every 5 years we're gonna replace the power strips, because that's how severe this puppy is. It is a limited equipment. You have to be mindful. And things that when they go bad, and if it's not done correctly, it's a very big fire hazard. For example, this is a Anchor power strip that I have that has surge protection, and it has a MOV that blown up. Now here's the deal, it does the MOV blew up, but you can notice this is like a very thick plastic and still blanketed this whole part. Now the reason why this only has this minor damage and I can still hold it is because it has a fuse. Many poorly built one do not have a fuse system, so they will not go to off state, they will simply go to unprotected state. You never want to buy something that goes to unprotected state. Like, dude, I bought a surge protector, if it's not working, just shut it off. I will throw it away and I'll buy new. Because if your equipment is serious enough, you do not want to run it without surge protection. So be mindful of those things, especially very cheap ones. You can easily notice, like the cheap ones where we like, yeah, the protection is off. They will have a small LED that's like protection off, and like you have to look into it. So generally that's a human error, and everybody makes error. Buy something that in case of a fault, it's like, nope, it's just like, nope, I'm not gonna work, I'm done, I'm not gonna work. So be very mindful. Bad ones are a very big fire hazard, and very high-end industrial ones, they are generally designed in a metal enclosure for that reason alone. Now how about doing it yourself? Now if you are patient enough, the thing that you will build will generally would be better and cheaper. For example, there are many super cheap systems that claim, like for example something like this. Now the company did not claim it, but somehow even its basically actual plastic molding has voltage surge spike protection designed to prevent damage from sudden voltage surges and spikes. I'm like, this does not have anything. I have opened it, I have physically opened it. There is no MOVs here, like nothing. And especially be very mindful, if you're buying something that looks a bit too cheap and to have like amazing level features, please open it up and check it, because I'm pretty sure, like, and you may like, I do not understand those circuitry. No, you will look at it and you're like, dude, this is a normal power strip versus this has some magical hoo-ha. It's very easy to detect. So be very mindful of that, and you can easily build high quality ones. The reason for that is like MOVs can be parallelized. Basically, you can have multiple mobs. Doing that, you will have the luxury of increasing the power rating. And even in Amazon, you can buy like for 300 rupees or like $2-3 100 pieces. I'm like, what the hell you gonna do with 100 pieces? Like, you can just parallelize it up. So you will see any people who are building these things, they have like 50 of these. The reason for that is like, and benefit of that, because you are spreading the load around 50 physical pieces, it like inherently lasts much longer. So you can build something cheaper and better. And if quality components are used, it will even last longer. And people who are serious about radio, audio, more often than not, they are like, they slowly start to like, yeah, this equipment is like, what, $800 for that? Okay, still I'm getting that. Okay, $9,000. Yeah, you know what, I'm gonna build it. And it's like, okay, for $150 I built something amazing. So be very mindful. And schematics wise, it's not that complicated. Inherently, it's not that complicated. The reason is just, it's not the MOF components are not something that you just go into buy in a normal store. That's why it's a bit daunting, but it's a normally doable thing. However, properly built one will not only have MOFs, they will have multiple other things. For example, one of the things that always is recommended is having fuses in these things, because when these MOFs are not designed as a conductor, they are inherently a resistor. So once they actually become a closed circuit and they started to conduct, they heat up too much, and you want to make sure that that state is not permanent. To make sure that it's not permanent, you will have a fuses there. Those will be triggered on thermal basis, like 150 degrees Celsius or 100 degrees Celsius, and the moment that temperature is like nope, so these things cool down, and that prevents from that fire damage. And whenever you are talking about like something very sensitive, you're like, dude, I'm using this weirdly built analog audio device, and it's like very sensitive to like very low level hummings, and you are like, how the heck humming is happening? If you have dishwashers, poorly built one, yeah, it's gonna create so many spikes, and it's like it's creating spike every time it's changing wash cycles. It's like, it's weird things. That's why I specified the lightning. Everybody thinks about lightning is such a small percentage. It's like yes, whenever it happens, it's a big deal, but it's like car accidents versus flight accidents. So, and there is another aspect. It would be easy to service and repair, because these things are inherently consumable. You can you would want the ability to, hey, this thing has served this purpose, let's replace it. Now you could even do something very simple. You can have like a box that supports DIN rail, and because DIN rails are generally designed for home appliances or industrial uses, and it's supposed to be in permanent installation. So the part that actually blows up, it's replaceable. It's a cartridge based system. You can just pull it out, plonk a new one in, done. If your equipment is valuable enough, going that route also would be valuable. So that's why I would suggest look into it, see things out. Like, I have provided a video down below that should give you some idea how the professionals do it, quote unquote. Now, this was my presentation on surge protects. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.